Hi there, everyone. Welcome to Maths with Lucanyiso for another video. Saw some people view the video that I posted on Sunday. I had like 59 views last time I checked, so I thought I should do another one. So this is the Grade 12 National Senior Certificate paper for September 2025 from the Eastern Cape, from the province of the Eastern Cape. We're still doing Maths paper 2. I'm mainly doing maths paper 2 because a lot of people struggle with trigonometry and geometry. I will get to the geometry questions as well, do a couple of geometry questions, some of the tricky ones. Um, but I'm just starting with the trigonometry because it's one of the sections that people tend to struggle with. So again, please like and subscribe to the channel, and I will keep posting more videos going through the content. And also, you can comment on the comment section in terms of which questions, of which papers, maybe share the links that you would like me to go through, and then I'll go through some of the questions. Now, the question I want to do here is the general solution question, which is specifically question 5.4. I'll just zoom in here. This question 5.3 also looks interesting. So the question 5.3 looks interesting. Maybe I'll do that one tomorrow or whenever I get time. But right now, I just want to focus on this question, the general solution question, which a lot of people tend to get wrong. But if you look here, this is a 7-mark question. And once you know the process of actually doing the question, it becomes a bit easier to get those 7 marks rather than to get 0 out of the 7 or to get part marks for the question. I always say the goal is to always get full marks for the questions that are systematic and that are always done the same way. Because if a question is done the same way over and over again, you would like to get full marks for it because it means if you practice enough, then you should be able to get full marks for it. So let's get into it quickly. So here we've got we want to well, the ultimate goal is we want to find the general solution of this thing. But we first need to simplify this into a single trig ratio of x. To do this, we're going to use trig identities. There's a trig identity which says that cosine A minus B is equal to cos cos A cos B plus sine A sine B. Also, we have cos A plus B is equal to cos A cos B minus sine A sine B. This is on the formula sheet, so you can always check it from there if you want to. But these are the trig ratios that we need here, right? So let's first apply this to the 5.4.1, right? We have cos 60 degrees minus x plus cos 60 degrees plus x, and we want to square this. We want to square everything. So obviously, let's first simplify what's on the inside. This is going to be cos 60 degrees cos x plus sine 60 degrees sine x, right? Now let's just put some brackets around there. Plus, now I want to evaluate this part. I want to evaluate this portion. This is going to be cos 60 degrees cos x minus sine 60 degrees sine x, right? And we are squaring the whole thing. Now, we need to just quickly mention something here in regards to special angles. I'll just draw a quick triangle. Okay, maybe let me do this here. If we have a right angle triangle A, B, C with the angle 60 degrees, 30 degrees, then this special triangle will have adjacent over hypotenuse in terms of the angle 60. So this is what I mean, adjacent over hypotenuse. This is going to be 1/2 because cos 60 degrees is a half. This is 1, this is 2. To work out the third side, 2 squared is equal to 1 squared plus BC squared. So BC squared is 4 minus 1. So BC squared is 3, meaning BC is the square root of 3. So this is the square root of 3. So we can see that cos of 60 degrees is adjacent of our hypotenuse, so it's 1 over 2. And sine of 60 degrees is opposite of our hypotenuse, so it's root 3 over 2. So now we're able to evaluate what's inside the bracket. This is going to be a half cosine x plus root 3 over 2 sine x plus, now when I evaluate this, this is going to be a half cosine x minus root 3 over 2 sine x, right? And we want to square the whole thing. But now if we just focus on what's inside the bracket, so I'll just move this down here. If we just focus on what is inside the bracket first, before we evaluate the square, we see that this is going to be a half cosine x plus a half cosine x, because these two will cancel. So, because it's root 3 over 2, it's plus root 3 over 2 sine x minus root 3 over 2 sine x. And we have this being squared. This is just cos squared x. And that is the answer to 5.4.1. We have simplified this ratio into a single trig ratio. Now we want the general solution of this thing is equal to 3 over 4, right? So that means now I just take, so this is 5.4.2. I just take cosine squared x is equal to 3/4, right? And I want to find the general solution of this. So what I'm going to do here first is I'm going to first say this is going to be, well, I mean, I can't really divide by cos here to have a cosine x. And I could simplify this. So I could simplify this to be 1 minus sine squared x. However, that's not really going to help me because I'm still going to have a sine squared x. So there's no point in doing that. What I can do though is I can say, well, this is cosine squared x minus 3/4 is equal to 0. And this is a difference of two squares because I can write this as cos x plus something cos x minus something. And I want this to basically be represented by the things that are going to be here. So I could just have root 3 over 2 and root 3 over 2, because root 3 over 2 times root 3 over 2 is going to be 3 over 4. And it's plus and minus, so it's going to be minus 3 over 4. This is going to be minus root 3 over 2 cos x plus root 3 over 2 cos x. That becomes 0. This is just going to be cosine squared x, which is that. So now I have that cosine x is equal to minus root 3 over 2, or cosine x is equal to root 3 over 2. Now x is going to be shift cos, you can do this in your calculator, root 3 over 2 this will be x is equal to, you can do this in your calculator or you can just go to your table, right? If I'm not table, the triangle. If I'm saying I want cos to be √3/2, then you can see from this special triangle that we are working with the angle 30 degrees. So this is actually just going to be x is 30 degrees. Now, this is very important. I'm going to say this is my reference angle. And you'll see why I'm saying it's going to be my reference angle when I actually find the general solution. I'm going to do the same thing on this side. It's going to be x is equal to 30 degrees. Again, this is my reference angle. Now let's first deal with this part, right? Let's deal with the left-hand side. This is going to be split into the second and third quadrants. Why? Because cosine is negative. And cosine, if you remember your reduction formulae or your CAST diagram, is negative in the second and third quadrants. That means this is going to be x is equal to 180 degrees minus 30 degrees plus the 60 degrees k. Or x is 180 degrees plus 30 degrees plus 360 degrees k. Why are we adding 360 degrees k? Because the period of a cos graph is 360 degrees. This will be 150 degrees plus 360 degrees k. This will be 210 degrees plus 360 degrees k. Now, let's continue and come to this side, the right-hand side. This will be in the first and the fourth quadrant because that is where sine, no, not sine, cos is positive. So x is equal to 30 degrees plus 360 degrees k. And we are done for the first quadrant. For the fourth quadrant is going to be 360 degrees minus 30 degrees plus 360 degrees k. And this is going to be x is equal to 330 degrees plus 360 degrees k. And that is the full solution for this question. And don't forget to say k is an integer. Now, why am I doing this? 180 degrees minus 30, 180 degrees plus 30, 30 degrees, 360 degrees minus 30. That's just based on your CAST diagram. That's how we define the CAST diagram. In the first quadrant, we have theta. Second quadrant, we have 180 minus theta. Third quadrant, we have 180 plus theta. Fourth quadrant, we have 360 minus 30, minus theta. And then again, like I said, I'm using the second and third quadrants here because my cosine, no, my cosine is negative. I'm using the first and fourth quadrants here because my cosine is positive. Maybe let me put a plus sign here. And that is how you find the general solution for that question. If there's any questions, you can comment in the comment section and I'll try and get back to you explaining whatever query you have. Thank you for watching the video and I'll see you in the next one.